Okay, hello and welcome to the next lecture. So we're still talking about functions. We have a lot to talk about for them, but we know how to make them now. We know the difference between returning, giving back a value, and printing, and so on and so forth. We can test our stuff. We know how functions get executed and return through this function call stack thing. We can use fancy references to change values of variables across function calls. Oh man. And then we were ending last time with talking about multiple files. So I guess the last thing that I want to talk about for this sequence is, for this little subsection, is that you should never use namespace standard inside a header file. And remember what a header file is. It's just a file that contains all the declarations of your stuff. Okay? Has a .h on it. And so it has your declarations. It's what the user needs to know to go and run your functions, and what the compiler needs to know to make sure that it's using your functions correctly. So what you should not ever do, though, is use namespace standard in a header file. Be like foo.h. You're like int foo. It provides the foo function, for example. But you shouldn't do this using namespace standard. And I'm abbreviating it for fun. So the issue is, of course, you're going to go and implement all this stuff in foo.cpp, ... But maybe in main.cpp, where you include foo.h, that's the important place where you include it. You don't have to in foo.cpp, but you usually do. When you say include foo.h, with quotes, what's going to happen is it's going to copy and paste this entire file here. And what if main didn't want to use namespace standard? What if main.cpp didn't want to use namespace standard? Well, that's just too bad, because by including this line in foo.h and including the file in main.cpp, it's just getting copied and pasted, and so this line appears in main.cpp. Suddenly you've included, you've used a namespace that you did not intend to use. Okay, so this is why for libraries you never use namespaces. Okay, that's the idea. So let's write this out in words, because including a header file just automatically copies and pastes all the code there. You shouldn't include any namespaces. Really, the only one you'll have to worry about in this class is standard. And the reason for that, if you are writing a file and you don't intend to use that namespace, but you include this header file that does, you're stuck with it. So you're kind of like forcing your opinions on your user of your library, and that's not good. So never use namespace standard in a header file, and hopefully I will give you an example of that in just a little bit. So what I really want to get into now is an extended example. I want to make a little counter library that keeps track of like some numbers, starts at 0, and then we can increment our counter, for example. We can be like, we have a count for our counter. We can get it, it starts at 0, and then maybe we can have an increment function that goes and changes the count to be not 0 anymore, but 1. And then, yeah, we can have fun with that. So I want to model this idea of a counter as a library. Okay? And this is a nice, good extended example, I think. So if functions aren't making sense yet, just keep on reading your textbook, keep on watching this lecture, and it really is just a matter of practice. So let's plan out this library. And let's make it happen. So we're going to initialize something, okay? We need to have some piece of information that keeps track of our count, okay? We need a count variable somewhere. Dun dun dun. Well, we could maybe make it a global count variable so that it lives outside and we can always get it. How about that? So first of all, we'll need a count variable. Oops. To keep track of our counter's count. Okay, and then we'll probably need some kind of initialization function. We'll initialize our count to be 0. Let's do this with a function. So maybe in main.cpp, when I use this counter library, I can say init, or like counter init counter, something like that. And that'll go and initialize our count to be 0, because any variable, you know, starts out being undefined. We want to make it have an actual value. And then we want to have like an increment function. We'll call it inc, perhaps. Oops. And again, it won't take any parameters because it knows what to do. It needs to go and touch this global count variable and increment it. Okay? And maybe we could also have a decrement as well. Let's see, is that all we want here? Maybe we could have a reset function. Reset the count to 0. And let's see here. What else? What else? You might be thinking that reset, well, it's going to do the same thing as initialize. Why make 2? But this is to prepare us for classes. Initialize will only ever be called once. Really, we could use the same function for both things in this case. But we're not for reasons, okay? And then, let's see here. How about a get count function? Give back the current count. Okay? I think that is what I want to do. So let's make this happen. Okay, so let's plan out our header file now. So this will be counter.h. And oops, we don't want that to be capitalized. So we need to pick what's going to go in here. All right, so let's see this. Well, we're going to need a count variable. We're going to put that in the CPP file because if we put it in the H file and we include it twice, there's going to be a duplication. That's beyond the scope of this class right now. It doesn't really matter, but this belongs in the CPP file. Oh no. What have I done? So there's only one of them, all right? Otherwise it makes 2 of them because we might include this header file twice. And then, all right, we're going to need an initialization function. That can totally go in a header file. We can say counter init. That'll be one function to initialize things. And then we'll have increment and decrement. And I wish it would not capitalize them. Let's see, what else? What else? Reset, to reset the counter to 0. Technically it'll be the same implementation as the initialization function. That's okay. And then a get count. And I could call the function get count like that, or another common way of doing things with 2 words is using underscores. Okay, so this will be what we put in our header file. We'll declare all of these functions. Okay, so I've gone and made a lecture 13 folder. I've got a counter folder inside of that, and that'll hold our library. Okay, so I'll say vim counter.h, and we'll put all our stuff. Remember your header file guards to make sure there's no infinite inclusion. Oops. Okay, so now let's write our functions. The first one's going to be init counter or what did I say, counter init, sorry. No, I set init counter here, and then I went and changed it, so let's be consistent. There we go. That'll be our first function. And then I guess we can put reset here as well. None of these take parameters, they just do things. And they're going to update a count variable that already exists. It's going to be a global variable, so these can be void. Okay, they're just going to update things. Counters count to 0. Reset will also set our count to 0. But the idea is we'll only run the initialization once, then reset. We'll set it to 0 after that. Okay? And then increment and decrement, again, take no parameters. They just work on the count function and they increment it. Or they decrement it. So you don't have to give anything back. Let's see what else. And then we'll have, I think it's just get count, yeah. This will give back the count. So it takes no parameters because it doesn't need to find anything. It doesn't need to be given anything because we know it's going to get the count and print it back out, or sorry, give it to the user so that we could maybe eventually print it or do things with the value. And so the return type can't be void here because we want the value back. We want the int that is the count. Okay? I hope that makes sense. And so that's our header file. This is what the user sees, and that's how they'll interact with our library. What we can do now is make a counter.cpp file. And it's common to include the name of the header file, counter.h. And so now we have access to all its declarations if we want to define things out of order. And now we can go and implement all of these functions. Okay? But the very first thing we should do is make that count variable. Global variable that keeps track of our current count. So in our program now, by putting that there, we now have a count variable that we can work with. Okay? It is a global variable. And so init counter is going to make it 0. It'll set the count to be 0. And so we'll reset. And I know we could make them both the same function, but for reasons that I will explain later with classes, this is a good idea. All right, then increment and decrement, they're going to increment the count and decrement the count. And then get count is going to give back the count. Okay? Return count. You see that? Now it made it all pretty. So here are our functions and our one global variable that all these functions work on. Okay? And so now, to make it all clear, let's use our library in counter.h inside of a main.cpp. Okay? So let's see here. We're going to include our header file, our counter.h, so we have access to the library functions, because everything got copied and pasted. Then I'll also include the normal stuff as well, because we're going to print things out. All right, so the first thing we need to do is initialize our counter. And if we didn't do that, it would have a weird value. So init counter. So now our count is 0, and I can print it out. Cout get count. All right, so this should print 0 for us when we compile this. And the way we compile it is because we have multiple files. We're going to compile every .cpp file. Okay, compile only the implementation files. The header files, they already got copied and pasted. No problem there. Okay. Are you ready? This is exciting. So we're going to print 0 here. And the way we're going to compile this is g++ standard equals c++ 17 main.cpp, and then also counter.cpp. And the name of this program can be called main. Why not? So let's copy that. And we'll say just like that. And oh man, did it compile. And so now, when I run this program, it's going to have, by virtue of counter.cpp, we're including all these files, or this file has been compiled for us. It's not been included, but it's been compiled. We have the program implementation for us to use. We have this count variable, okay? And that lets all of these functions work. All of these library functions work. So we can get our count and print it out. Hey, so that made our count, by calling this function, it made our count 0. And then we printed it out with get count, because that returns our count. And now we can increment twice, perhaps, and print out our count again. What should it be? Oh yes, it's 2. Very good. So then we can decrement it once, perhaps, print it back out. Oh yeah, now it's 1. Beautiful. And if we want to reset it, we can call reset. And bam, it's 0 again. Okay, so isn't this a cute little library where the user doesn't care how any of these things are implemented? That's the beauty of it. We just know, all we need to know is how to use these functions and what they're supposed to do. And that all can be done by looking at the header file. All right? So the user doesn't know that we named our count variable count, for example. We could have named it foo, as long as we used foo down here in all these implementation functions. The user doesn't know about this variable because it's not in the header file. So it would be incorrect for the user to start talking about count. Okay? So hopefully these 3 files make sense to you. Please yell at me in office hours or on Piazza if not. But this is the idea. We made a library that represents a counter, one of those cool things that you can click. We can initialize it, reset it, update its values by incrementing or decrementing it, and give back the count that we built up. And these are our implementations as well as the variable that we're using to keep track of everything in. Hopefully they make sense. None of them take any parameters because they're just going to do stuff with count. There's no need. And then only the last one returns something because we want back the count in that case. Okay? The rest of these, they just do something. And then main.cpp included our library and started using it. Okay? So please study this. This is a really good example, I hope. I hope it's helpful. Okay, moving on to const parameters. So if you remember const variables, const parameters are not a big jump. All right, so we like to use references when we can because it saves memory. Okay, it's not copying anything like we've seen. So the issue with using references, though, is you are able to modify the variables that you pass. That is one of the things that you can do with references, and that's what you'll be doing in your lab, for example. Sometimes you don't want that, though. Okay, sometimes you don't want to accidentally modify those variables, but you want the memory savings by using references. What in the world can you do? You can use const. Okay, so let me show you this. Let's go back out into the main folder now, and let's make a file called const.cpp. And you remember const is just like const double, d equals 3.14, for example. And now I can't touch d. If I try to say d equals d plus 1, well, I'm going to get an error. It's like, oh, this is read-only. All right, so we can't do that. That's the beauty of const. And the thing is, maybe I had another double. Double e equals 4.15, for example. I'm totally allowed to use that value in a const expression. All right, so const double f equals e plus 1. This is okay. I can use an e variable. I can actually set f to exactly e, and it's a constant. Okay, I can't touch f now, but it had no problem. C++ has no problem converting a normal double to a const. A normal updatable variable to a constant. Okay. Oh no. I hate when it does that. It's trying to make it pretty, but it's just not. It's failing. There we go. There we go. Okay. So that's the idea. And the reason that this is going to work for parameters is because there's that interfunction dreamland where all the parameters are getting set using just assignments. All right, so let's make a function called, I don't know, let's say +1. The +1 function takes a double, returns a double. And we'll have it take the double by reference. All right? And it'll give back a new double, that is that double +1. And, okay, so I can say cout +1 of E, for example. This will work. Let's watch it work. This is going to be const.cpp, const. So it's going to add 1 to 4.15, and it's going to give back 5.15. No problem. But the issue is, what if I don't trust myself? And you should never trust yourself as the programmer. I'm allowed to say d equals d plus 1 in this function. What? And so now, before my eyes, E has changed. If I print it out now, E has changed to 5.15. No, we did not like that. So this should not be allowed to change its variables. And so what we can do is all of this. We can get the memory savings of references, but we can put a const right here, okay? Const references give you the memory savings of references, but it makes it so that you cannot touch the variable. It treats it as a constant, okay? So now I can say, oh, let's call this +1 const to make it different. All right, so now I can say +1 const E, and then print E, and it won't change. And you can already see that it would give me an error if I were to do this. So it can't. All right, so it's guaranteed to not touch E anymore. The silly function changed it, but now we're not. Okay? So that is const in a nutshell. Use it in your parameters. It's wonderful. Okay? So use const references as much as humanly possible in your programs. Okay? And this will get very important when we talk about things like, I don't know, with strings and then our own classes and things like that. Okay? That's the idea there. All right, so moving on now to algorithm complexity. We've written some really cool functions. They've done some nice things. They've done some fancy things. Well, let's talk about how fast they are. And this is a CSCI 41 topic, by the way. This is just for your own information to make you a better programmer right now. I'm not going to test you on this subsection at all, okay? Your book might say a little bit about it, though, and I want you to understand it. So the idea is, I want to know how fast my program is. How in the world can I do it? There is a CTime library that you can look up on the documentation website, and it has the ability to count the number of seconds that your program runs. But, I mean, you can run a program on a toaster these days, so what's the point of counting the seconds? Like, let's do better than that. So the idea is, there are some, quote, basic operations that your computer can do immediately, very fast, okay? So there are things that are pretty much all single line statements, all right? So plus, minus, times, all those simple things, assignments, printing to cout, these are all half lies, but that's okay. In CSCI 41, it'll make more sense. Some things that are not basic operations, as hopefully you understand, are summing a vector. You have to go through the entire vector. That changes. There's a different amount of work being done. For different size vectors. Okay, so it's not basic. You can't do it immediately. All right, you can't take one step and do this thing. Okay, so this is the idea of basic operations are ones that take one step of execution. Oops. All right, that's what I wanted to say there, and I guess this is getting too large. Oh, that's probably why. Well, let's make the font smaller. I don't know why there's 2 extra lines there. That's weird. So yeah, calling a function also, because the function might do some fancy things. Reading a bunch of things, so anything that might involve a loop, that's going to take extra time. It's not one step of execution. Okay, so you can think of all single line statements that don't do anything fancy. You can call them basic. All right. So what can you do with that information? Well, you can make a mathematical function that defines how fast your programs are. You can count the basic operations and then write a formula in terms of the input size of your program. We usually call it n in computer science. And that will tell you on any machine, your toaster, your refrigerator, your computer, how fast, relative to the clock speed of your processor, if you've heard that term, how fast your program's going to run. All right, so just a quick little example of these things, and then that'll be enough for now. So to add 2 ints, that is, well, that's just x plus y, right? That's a basic operation. So it takes 1 step to do it, and we call that constant time, okay? We say that is constant time. That's the idea. And then summing n numbers, well, you have to go through them all. Like maybe you have a vector, boop, 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 and you have a sum variable. It starts at 0, and you need to start adding all those variables in one by one, one by one. And so you need to do things. You need to do some additions, some assignments. This is size n times, all right? So some constant times n, and we call that linear time. Okay, so you might read about that. And then to draw your n by n box of stars, well, how many stars do you need to print? You need to make how many cout statements? I'll just draw dots now. Well, you need to make n by n, so n by n total, n by n cout statements. All right, so that's n squared. And we'll just put a constant out in front just to be safe. And this is called polynomial time. All right, so it's a polynomial function. And so I do encourage you to think about this stuff as you write your programs. Like, oh, is your function having some kind of n squared amount of operations when really it could be only n? That makes a better program. It makes a faster program. So just think about that in the back of your mind. This is not something I'm going to test you on. Again, this is just something fun. And it will make you a better programmer, and you will be very ready, if you keep this in the back of your mind for this class, to take CSCI 41. All right, so the last part of this set of slides, we're almost done, I know. Functions are a mighty beast. Is this concept of algorithms, okay? So you can think about algorithms in many ways. I'm going to show you a method for doing it, okay? So we can think of an algorithm as an amount of some kind of state that we have. So, for example, our count could be our state, and the commands that we can perform that edit that state. Okay, change the state through commands. So we had increment, we had decrement, we had reset. All right, or just alter the state or give something back. So that's essentially what an algorithm is. We made a library of a bunch of different little tiny algorithms that represented a counter. So in computer science, I'm going to get philosophical for a second. In computer science, there's a bunch of different patterns for designing programs, and everybody likes their own. Like I like one called functional programming, if you want to look up that. But I'm going to teach you a simple one called state machines. All right, so there is a cookie cutter method for building good, beautiful, probably correct programs, and this is one of them. All right, so it's called a state machine. And what it does is it abstracts over processes, over the commands that you can do that change the state of the program itself. Okay, so here are some example state machines. Let me explain them. So this one is, let's see here, your life, I guess, or my life if I lived in New York City or something like that, or Boston, anywhere with a train. So maybe you start out, your initial state, like when you were born, you start out at home. It's going to be your initial state. And then you can take some actions to change your state. So I'm in the home state right now, and if I wake up and it's time to go to work, I can take the train, follow that to the work state. You see how this can help you keep track of your program? Like maybe there are some operations that only you can do in the home state and only you can do in the work state and the bed state. Okay, so that's the idea, and that will help you logically separate things in your program. Okay. There you go. That's the idea. And so now we take the trainer at work and we do a lot of work, and well, then it's time to go home. So we take the train again. This time we can follow it to home, to the home state. All right, so now we're back at home. Maybe we can have some other states that leave us in home, like eat, for example. And then it's nighttime. We have to go to bed now. So we'll transfer ourselves from the home state through the sleep operation to the bed state. And then once our alarm goes off in the morning, we start back out in the home state, and it's time to repeat the process. Okay, so hopefully you can see the benefit of this if we had a bunch of different states, a bunch of different operations, and we wanted to keep it all straight in our minds. This is a great way of thinking about things. And this one down here, it's kind of tiny. Let me make it bigger for a second. This is a model for Uber or Lyft or something like that. It's so if you want to go somewhere, you start out in the trip requested state, and then you make a payment. Hopefully it works. Maybe your credit card failed. If it failed, you go back to the state where you do not have a trip that you've requested, and you have to make a payment again. Okay, so after you've paid, a driver is assigned to come and pick you up, and then you're in that state until your program's over, or the driver's like, nah, I don't want to take this person this far. Okay? That's the idea. Okay, it's happy, I think. And then after you're done with all that, you're in the driver unassigned state. The driver can now take a new trip. Okay? And yeah, this is probably the way that the Lyft app or the Uber app has been implemented. It keeps track of all these different little states. Okay? So this is a very helpful thing to do in programming. All right? So that's the idea. So you group your program into states and actions that happen on those states. So, for example, let's pretend that you are my state machine now. As a student, you're a two-state machine. You have a learn state and a practice state, and you're going to alternate between the two. So you start out, your initial state, let's say, is learn, and at the very end of this class, your final state, and we'll draw that with a circle with another circle inside, and we draw the initial state with an arrow pointing at it. This is where you'll stop. You'll take the final, you will have practiced, there's nothing more for you to learn. All right? So you just stay in the same state as long as you're not done. So this is my model for you. You start out in the learn state. You're watching the lecture. While it's not over, you're going to keep learning, right? And then when I assign a lab assignment, for example, you're going to start practicing that, okay? And as long as it's not finished, you're going to stay in that state and keep practicing. Okay, hopefully that makes sense. And we're going to have a program example of this in just a second, so don't worry. And then when a lecture gets posted, you go back to the learn state so you can learn some more. Watch that lecture. Okay? So that is you as a two-state machine. All right? And now I have to have a meeting, and I will come back and record this after that. All right, I'm back. Let's do this. So we're going to count the words in a string using a state machine, and I'm going to show you how it makes the process easier. Okay, so assume we have some string, call it S, and inside of it, it has what's that one sentence with all the letters of the alphabet in it? The quick brown fox jumps over the lazy dog. There's a space, brown fox, dot dot dot, and that's a string. So think about it for a second, without looking down here, I guess. How would you count the number of words inside this string? And it's harder than you might think, because if you just count the spaces, well, I can mess up your algorithm by putting like 50 spaces at the start of this string. Boop. And in between words, I can put 2 spaces, things like that. So it's a bit harder than that. So, but the key idea is that because the white space separates words, we know whether or not we're inside of a word. Okay, that's the idea. We can have 2 states, inside a word or outside a word. Okay, and so I'm going to erase this now. We're going to draw it ourselves. Dun dun dun. Delete. Oh, almost all of it. There we go. Okay, so the idea is this. Oops, don't do that. Do that. There we go. So we're going to start out with our state. We are outside a word. Okay? And that's where we start. So we don't know until we see a non-white space character that we're inside of a word. And the second we see one of those, we know we have a new word. Okay? That is the idea. So we're sitting around reading spaces. Reading space characters. Keep it on reading those space characters. And the second we see a non-space character, we are now looking at a word. We're inside of one. And so maybe we're inside of the. So we saw some spaces, Now we suddenly see a new word. Okay? And so as long as we see word characters, non-space characters, we're still inside that word. Okay? Keep on reading the characters of that word. And then the second we see another space, we jump to the outside of word's state again. Okay? And so if we had a count variable starting at 0, when would we start incrementing? And the answer is the second we go from outside a word to inside a word. We found a new word. Okay? I hope that makes sense. We didn't see one, now we saw one. We're inside a word. So on this transition, if we added 1 to our count, this state machine will keep track of the number of words in a string. Isn't that cool? So let's code this up. We can make it a library too. Let's just code it up first. Let's make it all in one file. Call it word counting, perhaps. And we'll make main.cpp. And this one, right now I'm just going to implement it all in this file. But let's make it happen. So we're going to say, we're going to have a string that we're going to initialize with some line of code, or line of text. And you know from your Xylabs how to do that. You'd be like, get line, and then you give cin, and then the name of the string you want to initialize, and we'll call our string s, I guess. Okay, so now we've got a line of input from the user, and let's run our function. Count words, s, and we'll print that out. Alright, so what does this count words function need to take and return? Okay, we need to give it the string so that it can count that string. So we'll say count words, and it can take the string, but oh man, wouldn't it be nice if we saved some memory? We didn't copy it. But we don't want to edit the string, so we'll make it const. You see that? And so now we want this to output a number, right? So it needs to give back. It better give back an int, okay? Because that's the number. You can never have fractional words, I don't think. So this will be int count words, and it'll take a string. By constant reference, it'll take it. All right, so we're going to keep track of our count, and then we're going to start using this. Are you ready? So let's keep track of our state. We're either outside a word or inside a word. Okay? And you can use whatever variable you want to keep track of your state, but you use a Boolean. I'll just use a string. So state equals outside. So we're outside a word right now. That's our current state. And I'm going to read every character of this string. And go through every index of that string. So I can do it like this, or I can do the range-based for loop. Okay, so this will totally work. Maybe I'll do this just to remind you of it. Now, okay, so now I have a character. All right, so I'm going to put it in that current char variable. So see, or figure out which transition to take, depending on our current state. All right, so if we were outside a word, we can transition to stay in the same state or go to inside a word, depending on what kind of character we see. All right, so I'm going to include CSCI for the isSpace function. All right, and that'll tell me whether or not a character is a space character. So if my current character, and I'm inside the outside state, if my current character is a space, and this is how we use that, is space current character, well, then what do I do in that case? I'm still outside of words. I'm going to stay there. Okay? Technically, I don't need to do this because it's already outside. Else, it wasn't a space character. So I need to follow this transition to go to inside of a word. Okay? So change state to inside, and then also increment count, because we do both of those things. We started outside a word, we're about to go inside of one. We better increment our count and change our state. There we go. Okay. And now, well, if I wasn't in the outside state, I must have been the inside state. So let's take care of that one. And all right, how does the inside state transition? Well, if we're inside of a word and we see a non-space character, we're going to stay there. Or if we see a space character, we're going to transition to outside of a word. Okay. Well, let's see. If is space again, current char. So we are inside a word right now. We see a space, so we're going to transition to outside. And we'll say state equals outside. Otherwise, saw a non-space character. And this function from CSCI will work for tabs and new lines as well, so that's super nice. We get all that for free. If we saw a non-space character, well, we're still inside of a word. Technically don't have to say this again. Still inside the current word. All right, and so at the very end, we just have to return our count. Now that we've finished our counting, because at the very end of the day, we've iterated through every character in this string. We've seen every character, and so we know that our count is going to be correct as long as we followed all these transitions correctly and incremented our count as necessary. Okay, so let me show you this working. with an example string, and we'll go from there. So let's see, I want to go inside of word counting, G++, C++17, main.cpp, -o main. So my string is going to be the quick brown fox. And I'm going to mess this up. Oh no, sorry. I'm going to mess this up with a tab, 2 spaces, the 50 spaces, quick brown, 2 spaces and a tab, fox. 4. See that? It's going to keep on reading non-space characters, stay in the outside of word state, then it'll see, it'll keep on reading space characters, sorry, then it'll see a non-space character or word character, and then it'll be inside a word. It'll say count plus plus. My state is now inside. And so the next time we're going to hit these cases, right? Is it still a word character? Yes, stay inside the word, stay inside the word. Ooh, now we're outside a word again. We're ready to see a new one and increment our count. Okay? Hopefully that idea makes sense to you. This is a fun little example of state machines. And so now let's just make this a library to get practice with that. So what we can do is make this our one library function. So we'll say count words.h. We'll have our header file inclusion, just like that. And we'll declare our function. That's going to live in our library, just like that. And now it's going to complain, dude, what's string? I don't know what that is. You haven't included the string library. So we got to do that. And then remember, don't use namespace standard. Oh no. Oops. Oh no. What is going on here? Dun dun dun. Is it happy? Oh, I'm in caps lock mode, that's why, sorry. There we go. Don't use namespace standard here. And so what you need to do instead, it's like, I don't know what string is, dude. You gotta say standard string. You can't say using namespace standard, so you have to say standard string here. Alright, because if you use namespace standard, whoever included this file suddenly included namespace standard, and they probably didn't want to. Right? So now let's go to countwords.cpp, and it's common to include the header file, and it's a good habit of getting into. And now we'll include the implementation of countwords. Whee! There it goes. And we'll put it in the countwords.cpp file, save it, dun dun dun. And in the CPP file, remember it's getting copied and pasted everything from here, and that already included the string library. But if we want to use string by itself here, we're allowed to now use namespace standard in a non-header file. Alright, so now it's going to be happy. And remember, we've already included string from here. It's getting copied and pasted. And so now, we just need to include this in our main file, and suddenly we have the countWords function again. Okay? And so that's about it. To compile, G++ standard equals C++17. We got to give both the implementation files, main.cpp, countwords.cpp. That was the name of it, right? Yeah. All right. And we'll say -o main, and we've got ourselves a working file. Let's compile and run this. So again, we're compiling it with all the stuff, and the output's not going to change. I mean, it's all going to do the same stuff. Okay, 9 words. 1, 2, 3, 4, 5, 6, 7, 8, 9. Beautiful. All right. So that's all I wanted to share with you today. And that's all we have for functions. So here are some exercises for you to optionally do to make yourself, get yourself up to speed with these functions, make it faster, make it cooler. All right, so the first thing that you can do is write some tests for the counter library. And this would be very helpful. Like, how do you trust it? So tests for the counter library would look something like init followed by inc followed by, or let me just say it like this, init, then inc, then inc, then inc, then dec, then get count should return 2. You see that? So that's the kind of test that you'd be writing. Dun dun dun. Okay, that's one thing. Use multiple libraries now. Use our counter library to implement word counting. So you'd include one library inside the other. And now you'd be compiling with a bunch, with at least 3 CPP files now, because you've got your main.cpp, your implementation of the counter library, and then your implementation of the word counting library. That's a cool idea. And then you've had a bunch of previous Xylabs or labs, and they've had very long main functions. So one idea for you is to break up those previous labs or Xylabs into functions and see what kinds of types are involved. What should they return? And the idea of functions is they're here to make your life so much easier, to separate a bunch of things that are not really interrelated but kind of are, only in a very general sense. So we have a bunch of pieces that have some interaction between each other. And instead of putting all of this in one main function, we just kind of use them in the main function to do one thing. You see that? It kind of separates our concerns about things. There's like, here's our main function. Here's all our library stuff. They interact with each other, and we can interact with them, but we don't have to interact with everything. Okay? It helps us split up things in our mind. A nice logical separation. That's what functions are good for. Yeah, I think that's all I wanted to say there. That's a very long 3-lecture set of slides, but now you are masters of functions. So that's where I want to leave you for this lecture, and I will see you next time.